Now let us see the hydrostatic force acting on a surface which is vertically oriented. So this time the pressure force is not the same because we have studied the pressure variation takes place with height. So this is our x-axis, this is y-axis and this is z-axis, and you see we have a plane that is lying on xz axis and we have an area like this. So we have an area like this. So the fluid is here everywhere and the fluid is subjected from hydrostatic pressure from that side. So we take a small area dA and the pressure force dF will be that P into dA. So this is the pressure force into dA. Now let us, you can see this is our water level. This water is here and we measure this height Z from here. So you can assume this as Z. This is the water level. You can see the water is up to here, suppose I say. So consider a plane surface, the surface is plane. Consider a plane surface which is immersed vertically in a fluid, in a liquid. Now let us consider a small elemental area of dA area. So now we have dF is equal to, suppose I say this is Z, so this is Z and you see this is Z rho g, that is the pressure into area. So Z rho g into dA is the area. So the total force P F is integral dF and is given by Z rho g into dA, that is rho g into Z dA. So this is the net force, and this net force, in order to calculate, we have to evaluate this thing. Now suppose the area of the whole this is denoted by A, then what we do, this F will be rho GA times this is ZdA by A, we can do. Now you see this term, we can write this term as Z bar, that is integral ZdA by integral dA, that is the Z coordinate of the centroid of this area. So we can write this as F is equal to rho GA into Z bar, that is the total force is rho G Z bar into A. This is the force. So now you see, suppose this Z bar is a point called here. This is Z bar. The Z bar means this is the center of gravity. I denote it by G, and the distance from this top surface is Z bar. So the total force, thus the total force acting on the vertical area is the pressure acting on the centroid of the area times the magnitude of the area. So what we do, this is the quantity, that is the pressure at the centroid of this area times the total area. This is the expression for the total force. So now let us take some examples to tell how to calculate this. Now suppose I have a square vertical surface of an aquarium in which water is there up to this. I want to know what is the total force acting on the side walls. So the very idea is that suppose this is a square, so this is A and this is A. So the center of gravity of this area is at its geometrical center. So the force will be, total force acting will be that pressure at this point. So this point is at a distance of A by 2. So this is A by 2 rho G. This is the pressure into the whole area, that is A square. So we have A cube rho G by 2. Similarly, if I have a prismatic cross section like this, and if we have water filled inside it, then you see the centroid is here. Suppose this height is h, so the force will be given by, this height is h, so this will be 2/3, 2 by 3h. The centroid is at the 2/3 position of this. So if this height is at 2h by 3 rho g, this is the pressure at the centroid of this into that area. So this area means, suppose this is B, then half into base into altitude. So this will give the total pressure. So the expression for total pressure, you see, is equal to Z bar rho G. This is H rho G. So that means the pressure at the center of mass into that area. This will be the expression of the total force acting on a vertically submerged surface.